Uh, Today we are going to use how to make a simple circuit in PSIM. Last section we have learned how to design a simple circuit in PSIM. But this kind of simulation software is a software designed for power conversion. So you can design a circuit like a rectifier, bucket converter, inverter, cycle converters, and any kind of circuit that related to power conversion. So this PCM is a good simulation software and perfect so that can help you to design a simple circuit in that kind of simulation software. So kind attentive and before we start to make a simple circuit, make sure that you subscribe to our YouTube channel called EcoAgroIntellex so that you can get update to any kind of video uploaded to our YouTube. So in order to start, first of all you have to install your PSIM. But in my PC I have already installed it. So this is how it will work, the icon. So you click here. This is how it will look, and let's zoom. So it have a different tab. It, it have file, edit, view, subcircuit, simulate, option, utility, window, help. File, here you can create a new sheet. You can open existing project. This is where you can see subcircuit, where you can simulate, but this feature, you see, it is not highlighted. It's unlocked when you start to design a circuit. This is our option: auto learn, sim view, windows, and help, where you can get help, where you can get online tutorials. So if you design a circuit and fail to design it, you can click here and direct it to the YouTube online tutorial so that you can understand how to design a circuit in a PSIM. So, and this is a toolbar, button toolbar. Here there is a different kind of tools. So let's click new file and click new for the new sheet and zoom. So this is the workspace. You see, this is the workspace. And here, this is a ground, this is a resistor, this is inductor, this is capacitor, this is diode, thyristor, MOSFET switch, IGBT switch, single phase diode bridge, three phase diode bridge, getting block for switch, on switch controller, voltage probe node to ground, voltage probe between node to ground, so oscilloscope, source, DC voltage source, you see, AC source, sinusoidal voltage source. We have different kind of instrument, ammeter, voltmeter. So because we are going to make a rectifier, we have to list the component we need so that we can design as a circuit as which can do what you expect to do. So you will click here on A, means test. You see, uh, here on file, let me repeat. This is where you can open existing document. Can open existing document. Uh, uh, Okay, so we need uh we need those kind of equipment. So here uh we need a component like we need the component like diode, uh three sine wave or sinusoidal, which will provide AC source, and we'll need a transformer. We'll need ordinary diode also, and we'll need a resistor load, and also we'll need the measuring instruments such as voltmeters, uh, ammeters, and so forth. So let's start. Uh, because we need a source, we'll click here on button toolbar and click source, and also we need a transformer. You move two element and click on power. This is where you can search a component which is in the family of resistor, inductor, capacitor branch. Here is a resistor, inductor, capacitor, electrolytic, other resistor, inductor. So those kind of component, and we have switch, diode, thyristors, you see, magnetic element. So if you click on 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 tab, we will get sub. If you click on menu, we get sub menu. So because here we need the transformer, you will click on power and click on transformer and select ideal transformer and place it in your circuit. You see, this is a transformer. So also we'll need ordinary diode. You will click here. This is ordinary diode, and we will need a resistor. You see, click here resistor. So also we need to rotate it. This is a rotate. Control Z. Uh, you need a resistor to rotate resistor. We will rotate to the 90 degree, you see, and drag so that you can arrange your circuit properly. Then we are going to make a connection. So this is a wire. You click on wire and then make a connection. You see, make a good connection. You see, connect transformer to the diode. You know that the reason why we need the ordinary diode in rectifier, diode it have ability to allow current to pass in only one directions. That its ability. So we need to display this component, or what we call labeling. Double click on the component and display it, you see. And here we double click on the component and display it, you see. And also here double click on that transformer and write maybe transformer, so that anyone can understand this circuit. Transformer. We need also a source. This let's call VS, and then display it. So also once you finish to arrange your circuit and connect it properly, this PSIM provide option to see the waveform, we need to connect the instrument so that we can view the waveform in a good way. So we'll use a voltmeter to measure the voltage across that diode, and to measure the voltage across that resistor, and to measure the voltage across this source, and rotate, yes, and rotate this, you see, and then click to wire and connect it. and connect it. So finally, we need also to connect the voltmeter to the diode so that we can measure the voltage across the diode. And sorry for that issues. So after connecting the voltmeter, make sure that you connect the voltmeter in parallel because voltmeter has high resistance. So also we need to connect the ammeter across this diode. See, Control Z and delete this wire and take ammeter, then connect ammeter to the circuit. You see, finally we connect the ammeter to the circuit, and also we need the simulation control. Click on simulation control. This is simulation control, and select all right on total time 0.1. Then wait and then run. In order to get the output, click on simulate, run simulation. You see, this is the interface, and we need to add. So let's add resource, click add, then press OK. This is how a sinusoidal waveform it look. As I have introduced at the beginning of the video, this is a circuit that will convert AC to DC. So, and also we need to add V output, add, you see, and also we need to add current output, add, you see, then finally we add signal across diode. So this is the waveform. So you see, we have a sinusoidal waveform. So this diode allow a half of wave which is positive to be rectified. Voltage output and current output. So this is a voltage across diode. So the PSIM help us to know the help us to build the circuit related to power conversion. So thank you for watching, and I recommend you to make subscribe for this channel.